Okay, so in this video I'm going to be recording solutions for the VCAA Further Maths Exam 1 from 2018. So Exam 1 in Further Maths being a multiple choice examination comprising 40 multiple choice questions. For the purposes of this video I will only be recording the core sections, the core questions, which is 24 multiple choice questions, and then the Matrices module, which is the most commonly completed module, so that will be an eight further multiple choice questions. Obviously this year in 2020 students will only be completing core plus one additional module, and there will be more questions in each module so that it still comprises 40 multiple choice questions in total. Okay, let's get working through the questions. So the first part of the exam is the data analysis section, which will be 16 multiple choice questions. Alright, so let's have a look. Use the following information to answer questions 1 and 2. The dot plot below displays the difference in travel time between the morning peak and the evening peak travel times for the same journey on 25 days. The percentage of days where there was 5 minutes difference in travel time between the morning peak and the evening peak travel times is... Okay, so if we have a look, 5 minutes difference. Now this is an interesting question because actually you see there's also negative differences, just meaning that if they're doing the calculation by doing, you know, evening peak minus morning peak, then, sorry, evening travel time minus morning travel time, then perhaps for most times it's a positive difference. The evening time's always a bit longer, but there's a couple of days where the evening time was quicker, so there's some negative times here. So where it says a difference of 5 minutes, technically -5 would also be a difference of 5 minutes, but fortunately there aren't actually any days on which there was a difference of exactly -5. So we only have 1, 2, 3, 4, 5 days out of, it tells us in the question that n is 25 without the need to count, and so that is 5 out of 25 days, which many of you can probably do in your head. That's 1/5 or 20%. Obviously your CAS can help you if you need it. Try again. 5 out of 25 times 100%, so 20%. So C. Okay, question 2. The median difference in travel time is, okay, so again we have 25 pieces of data, so therefore the median is going to be the 25th plus 1 divided by 2, so the 13th piece of data. Okay, the median isn't 13, the median is the 13th piece of data. Okay, so we want to count, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's my median point there, which is a difference in travel time of 3 minutes. So A. Okay, questions 3 to 5 use the following information. So the pulse rates of a population of Year 12 students are approximately normally distributed with a mean of 69 beats per minute and a standard deviation of 4 beats per minute. A student selected at random from this population has a standardized pulse rate of Z equals -2.5. This student's actual pulse rate is. Okay, so there's two ways you can do this. You can understand what the Z score tells you. The Z score tells you how many standard deviations away from the mean is the particular value. So this means that this is a value that's 2.5 standard deviations below the mean. So I can simply, if I recognize that, I can simply do 69 minus 2.5 lots of the standard deviation. So 69 minus 2.5 times 4 is going to be 59. So it should be A. Alternatively, you use the formula, which is on your formula sheet. So Z is equal to the X value minus the mean of X divided by the standard deviation of X. Okay, so in this case, Z is going to be equal to, and we know what Z is, so -2.5 is equal to our unknown actual value minus the mean, which we know is 69, and divided by the standard deviation is 4. And when we rearrange or solve that equation, we're essentially doing the same calculation as this. We're going to multiply by 4, so -2.5 times 4 equals X minus 69, so that's -10 equals X minus 69, and adding 69, so X equals 59. Or you can get your CAS to solve that equation for you, to again tell you that the X value must be 59 beats per minute. Okay, question 4. Another student selected at random from this population has a standardized pulse rate of z equals -1, so they are one standard deviation below the mean, so that would be 69 minus 4. The percentage of students in this population with a pulse rate greater than this student is closest to. Okay, so the key thing is really just about how many standard deviations away from the mean are. Z equals -1. If we use the Z scale instead, is just one standard deviation below the mean. Now we know that within one standard deviation of the mean, we know that that's 68% using our 68, 95, 99.7 rule, which means that this bit of area out here is 68 minus 100 minus 68, which is 32, and half of that, which is 16%. Okay, so that means that we've got 68% plus 16%, which is 84%. Again, of course, you've got your CAS available to help you with the number work if you need to. So 84% of students will have a pulse rate greater than this student. So option E for question 4. Okay, question 5. A sample of 200 students was selected at random from this population. The number of these students with a pulse rate of less than 61 beats per minute or greater than 73 beats per minute is closest to. Okay, so we need to work out how many standard deviations above or below the mean 61 and 73 are. So 61 is 8 below the mean, that's 2 standard deviations. 73 is 4 above the mean, that's 1 standard deviation. So if you think about what you have happening here, so 69 is in the middle, the standard deviation is 4, so 73, 77 and 81 and 65, 61 and 57. Alright, so number of these students with a pulse rate of less than 61 beats per minute, so that's down here, or greater than 73 beats per minute, so that's up here. Okay, so that's below 2 standard deviations. Okay, so we know that there's 95% between 2 standard deviations, which means there's 5% not between, so 2.5% either side. This is 73 is 1 standard deviation above the mean. Same logic we used up here. This is 16%. Okay, so that means we've got 16% plus 2.5%, so 18.5% of people fit in this category. And we know that there's 200 students, so 200 times 18.5%, so 0.185 is going to give me 200 times 0.185, 37 students. So B. Okay, question 6. Data was collected to investigate the association between the following two variables: age, 29 and under, 30 to 59, 60 and over, and uses public transport, yes or no. Okay, so these are two categorical variables. So the question is about which of the following is appropriate to use in the statistical analysis of this association. So if you have two categorical variables, a scatter plot is going to be useless to you. A scatter plot is for two numerical variables. Parallel box plots, you need one numerical variable because you're going to have your numerical scale, and then you can have, two categories where you do two different box plots for the two categories, category 1 and category 2. But you need a numerical scale at the bottom, so that's for one numerical and one categorical. So B is not going to work, parallel box plots. A least squares line. A least squares line is something to do with the scatter plots. That's also about two numerical variables. A segmented bar chart can work, and the correlation coefficient is also to do with the least squares regression line to do with the scatter plot. That needs two numerical variables. So it's the segmented bar chart. So in the segmented bar chart, we can have our, 3 different age groups here, under 29 and under, 30 to 59 and 60 and over, and then we can have our bars for each of them representing, and we can have, this percent is yes and this percent is no, this percent is yes and this percent is no, this percent is yes and this percent is no. So we can do a segmented bar chart with two categorical variables. The other option for two categoricals would have been a two-way frequency table, but obviously that's not an option. Okay, question 7 to 9 use this information. So the scatter plot below displays the resting pulse rate in beats per minute and the time spent exercising in hours per week of 16 students. A least squares line has been fitted to the data. Question 7. Using this least squares line to model the association between resting pulse rate and time spent exercising, the residual for the student who spent 4 hours per week exercising is closest to. Okay, so we know that residual is actual minus predicted. Okay, so the student who spent 4 hours per week exercising, so that's here. Okay, so the actual value is 63. The predicted value from the regression line is about 64. So 63 minus 64, so that's going to be a residual of about -1, so option B. Okay, so question 8. The equation of this least squares line is closest to. Okay, so this becomes a combination of looking at what your options are and calculating some information from your plot. Now this is a fairly common thing they do. The key thing to note here is that this here is not the origin, okay? 0 time would be about there, and 0 resting pulse rate would be, you know, way down here. So in terms of if you actually draw the x and y axes, you know, the y-axis is over here, but the x-axis is kind of way down here. That would be 0, 0. So in terms of thinking about the intercept is going to be up there somewhere, okay? So it's really important. So it looks like the most common mistake people will make is they'll assume that the intercept is about 67.2 or 0.25 or something like that, but actually it's going to be up here past 68. So that's the first thing I'm going to look at here. Looks like it's going to be this 68.3, not the 67.2. So I'm going to rule out A, B, and E. So it's definitely between C and D. One of the other things you want to look at too that can be easy to discriminate here is whether they've got the explanatory and response variables around the right way. In this particular question, they've given you the same, it's got time here and resting pulse rate here in all of the options, but sometimes in these kind of questions, those mix around. So it's correct that time is explanatory, so that should be this over here, so that's correct. So we are going to need to calculate the gradient. It's going to be, it's clearly negative, so also we could have ruled out this one pretty quickly on the basis of a positive gradient. We just want to know whether it's about -0.9 or about -1.1. So we need to calculate an estimate for the gradient. So you essentially want to kind of approximate these points here. Based on what it says here, it looks like that we can approximate that as being 67.2. So we're looking at going from 167.2 to this point down here, which is about 1156.2. Okay, so in terms of, you know, rise over run, 67.2 minus 56.2, so that's a rise of 11. Okay, that distance, that vertical distance is 11, and the run we're going from 1 to 11, so that's a run of 10. Okay, so your gradient is rise over run, and your slope is rise over run, and so that's going to be approximately 11 over 10, which is approximately, hopefully you can tell, definitely not 0.1, sorry, definitely not 0.9. It's going down, sorry, we also should have said it's negative that, so it's -1.1. Okay, so about -1.1, so therefore option D should be the correct answer to question 8. Okay, question 9. The coefficient of determination is 0.8339. The correlation coefficient is closest to. Okay, then again, this is another common question. So we know that r squared is 0.8339. And so therefore we can work out r by taking the square root. Now the key thing when we take a square root is that it could be positive square root of 0.8339 or negative square root of 0.8339. Okay, and you can see that if you solve this equation with your CAS, if you say, well, I know that r squared equals 0.8339 and solve that for r, you're going to get both a positive and a negative value. So you need to think about both, because in this case, we know that the correlation coefficient is going to be negative because of the negative slope. We can see that it goes down, it's got a negative association. So we want the negative 0.9132. Obviously, you don't need to get your CAS to solve. You can just do the square root of 0.8339. 0.8339, and know that you need it to be negative, so negative 0.913 is the closest option there, so A. Question 10. In a study of the association between a person's height in centimetres and body surface area in square metres, the following least squares line was obtained. Which of the following is a conclusion that can be made from this least squares line? An increase of 1 square metre in body surface area is associated with an increase of 0.19 centimetres in height. Now that's around the wrong way. It would be for every 1 centimetre increase in height, the body surface area is increasing by 0.019 square metres. So the variables are listed around the wrong way there, so it's not A. An increase of 1 centimetre in height is associated with an increase of 0.019 metres squared in body surface area. Now that looks to be correct to me. Let's just check through the other options. The correlation coefficient is 0.019. No, that's the slope. That's not R. Okay. A person's body surface area, the correlation coefficient could be that, but we don't know what it is. So we can't answer that from this equation. A person's body surface area in square metres can be determined by adding 1.1 centimetres to their height. No, you need to take their height and multiply it by 0.019 and then take away 1.1, so it's definitely not correct. A person's height in centimetres can be determined by subtracting 1.1 from their body surface area in square metres. That's also not correct. A person's height could be obtained by adding 1.1 and then dividing by 0.019, so no. So definitely option B is the correct option. That's the interpretation of the slope. An increase of 1 centimetre in height is associated with an increase of 0.019 metres squared in body surface area. Question 11. Freya uses the following data to generate the scatter plot. The scatter plot shows that the data is nonlinear. To linearise the data, Freya applies a reciprocal transformation to the variable y. She then fits a least squares line to the transformed data. With x as the explanatory variable, the equation of this least squares line is closest to. Okay, I can rule out D and E because she's doing the reciprocal transformation to the y variable, so it should be 1 on y equals something to do with x. So I'm definitely going to rule out those two. I'm also going to speculate. Oh no, it's a reciprocal transformation. I was going to speculate that it should have a negative slope, but the reciprocal transformation actually changes the data quite a lot. So let's not speculate here, let's do some calculating. I'm going to insert a list and spreadsheets page, and I'm just going to insert my data. So I'm just going to perhaps pause the video while I do that, and then I'll come back to do the transformation. Okay, I've entered the data in the CAS, and as I always remind you, please take care when entering a data set into the CAS during an exam. One number out or a couple of numbers around the wrong way, and you're going to get a very different answer. At least with multiple choice, it might still be close, and you can guess from there, but do be careful. Okay, I always call my variables x variable, y variable, or xv, yv. It's really important that you don't name columns of data just by a single letter. Creates all sorts of problems in the calculator screen then when you're trying to solve equations and all sorts of things. So best to use more than one letter when representing a list of data. Okay, so I'm going to do my transformation. So I want a reciprocal transformation for the y variable. So I'm going to name this column recip y. And this column is going to be equal to 1 divided by the y variable. And that will fill down for me, and then I'm going to do the regression, menu 414. My x list is going to be my x variable, and my y list is reciprocal of the y variable. Alright, so we've got our regression over here. Alright, so it should be 1 on y in place of y, so we've already decided that. A, B option, it's A, B or C. And then it's clearly going to be, the A value is negative 0.0039, so that's this, plus 0.0179, so that would round to 0.012x. So A is the correct least squares regression line. Okay, question 12. A log base 10 of y transformation was used to linearize a set of nonlinear bivariate data. A least squares line was then fitted to the transformed data, and the equation of this least squares line is. This equation is used to predict the value of y when x equals 1.1. The value of y is closest to. Okay, so subbing x equals 1.1 into this equation. So log base 10 of y is equal to 3.1 minus 2.3 times 1.1. Now, we can get our CAS to solve that at this point. So we can solve, oh sorry, that's not what I meant, menu 3.1, let's try again. It's okay, solving log base 10 of y equals 3.1 minus 2.3 times 1.1 for y. and we get that y is approximately 3.7, so it looks like E is the correct answer. Alternatively, we can calculate the value of this right-hand side ourselves, 3.1 minus 2.3 times 1.1, which is 0.57, so we know that log base 10 of y equals 0.57. You could then get your CAS to solve this equation at this point, or if you know something about how logs work, you know this means that y will equal 10 to the power of 0.57, and so we can then just type 10 to the power of 0.57 into our calculator and again find that it is 3.7 approximately, so E. Okay, question 13. The statistical analysis of a set of bivariate data involving variables x and y resulted in the information displayed in the table below. Using this information, the value of the correlation coefficient R for this set of bivariate data is closest to. Okay, so this is where we need to make use of, on our formula sheet, these formulas here. In particular, we're going to want that one there because it involves R, and R is what we're trying to find. So we know that B is equal to R times the standard deviation of Y over the standard deviation of X. Now we've got B, because B is the slope of the line, 1.31, equals R times standard deviation of Y is 3.24 divided by standard deviation of X, which is 2.33. Now again, we can get our CAS to solve this equation right from here. 1.31 equals R times 3.24 over 2.33 for R. And so R is 0.94, so option D. Alternatively, you can work out what you can do a bit more of it by hand yourself. 3.24 divided by 2.33, well, that's that. So I've got 1.31 equals R times 1.39056, well, 0557, etc. Okay. And that means that R will be 1.31 divided by that. Okay. And then we can do that 1.31 divided by this value, which is also 0.94. Okay, so whatever way is more efficient for you in using your CAS, and that will depend on how comfortable you are with the algebra of those simple little equations. Question 14, a least squares line is fitted to a set of bivariate data. Another least squares line is fitted with response and explanatory variables reversed. Which of the following statistics will not change in value? Now this is interesting. So this is kind of thinking about, okay, if you had your data, your explanatory and your response, and you switch them, okay, it won't change. It'll still be a positive association, okay. If as explanatory goes up, response goes up, well then if you were to reverse those, it's still true that as response goes up, explanatory goes up. So the data it'd just be on a slightly different slope and in a slightly different position. So in terms of what would and wouldn't change, the correlation coefficient wouldn't change because it's still going up and it should still, no, that's okay. I just second guessed myself for a minute there. So if you swapped them, you'd have your regression line will change, okay? But it's still going to be as closely correlated to the data because the data is actually still the same. All you're really doing is kind of creating a mirror image of what's happening, okay? So it should be the correlation coefficient, C, which won't change. The residual values will change. They'll be slightly different just because of because the residual values are all to do with how the value compares vertically to the regression line, and when you've switched the values, that's going to be different because you're essentially switching the x and the y coordinates. So here you're interested in how do the y variables differ, and on the original graph that would be equivalent to how do the x variables differ. So that wouldn't be the residual. The residual would still be this. So the residuals are going to be different. Predicted values. The predicted values will be different. You've got a different regression equation. Some of them might be the same, but they won't all be the same. The slope of the line will definitely change, okay? And I guess, again, unless it's a perfectly symmetric set of data that goes right at the middle here, but that's unlikely. And the intercept of the least squares line, yeah, that could change. So if your original, so I drew a rough sketch here where I've got the intercept of the first line here and the intercept of the second line down here, so the intercept could change. It's the correlation coefficient. The strength of the relationship is the same no matter which way you, which is the response and which is the explanatory, but then all the nuts and bolts of that, so the actual regression line, the residuals, etc., are going to change. That's quite a tough question. It requires quite a thorough understanding of what's happening there. Question 15. The table below shows the monthly profit in dollars of a new coffee shop for the first 9 months of 2018. Using 4 mean smoothing with centering, the smoothed profit for May is closest to. Okay, so smooth profit for May, 4 mean centering, smoothing with centering. So we need to use 4 data values, but they're not going to be centered around May because it's an even number of data values. So 4 data values with May slightly to the right in the data values is going to be those 4. 4 data values with May slightly to the left is going to be those 4. And then once we've calculated those 2 separate averages, we're then going to average those. Okay. So this average is going to be, let me do this. So we're going to have 2402 plus 2456 plus 4651 plus 3456, dividing that by 4. So that is 3241.25. And then the next 4, so the numbers highlighted in green, we add those together, 2456 plus 4651 plus 3456 plus, oh sorry, I've missed one, haven't I? Oh no, sorry, 2823. I was looking at the yellow highlight. Divide by 4. That average is 3346.5. And then we center by averaging these two values. So 3241.25 plus 3346.5 and dividing that by 2. So we're going to take that value plus that value and then divide by 2, which is 3293.875. So closest to would be 3294, which is option B. Okay, and then the final data analysis question. The quarterly sales figures for a large suburban garden centre in millions of dollars for 2016 and 2017 are displayed in the table below. Using these sales figures, the seasonal index for quarter 3 is closest to. Okay, so we want to calculate the average for 2016, which is going to be 1.73 plus 2.87 plus, 3.34 plus 1.23. Divide that by 4. So average here is 2.2925. Okay. And this average for 2017, 1.03 plus 2.45 plus 2.05 plus 0.78. Divide that by 4 is 1.5775. Okay, so then we want to work out just the seasonal index for 2016, which would be 3.34 divided by the average for 2016, 2.2925. 3.34 divided by this number we worked out up here. So that is 1.4569. There's more than that, but that's okay. And then we want to work out how the quarter 3 compares in 2017 to the seasonal average for 2017. So 2.05 over 1.5775. 2.05 divided by this, 1.2995. And then we're going to average those to get a better seasonal index. You want to do that for as many years as you can and average that out to give the best possible overall seasonal index for quarter 3. So I'm going to average these values, so that plus that, and divide it by, careful about brackets there. We'll do it as two separate calculations and divide it by 2. So that's going to be 1.37822, etc. So index for quarter 3 is closest to 1.38, so option C. Okay, so that's the end of the data analysis, so on to the recursion and financial modelling. Use the following information to answer questions 17 and 18. So we've got a recurrence relation which describes the value of an annuity investment in dollars after n years. So we're clearly adding on some interest because we're multiplying by a number bigger than 1 every year, and we're also adding in payments regularly. What is the value of the regular payment added to the principal of this annuity investment? $500. So D. Question 18. Between the second and third years, the increase in the value of this investment is closest to. Okay, so we know that V0 is 46,000, sorry. So I'm just going to... Okay, so, and then we know that we multiply by 1.0034, sorry, and add 500. So that's the value at the end of 1 year. And then that's the value at the end of 2 years. So V2 is 47315.03. And the value at the end of 3 years would be recurring that again. So 47975.90. So the value, the increase in value between the second and third years is going to be that. So we want to do, sorry, that's a 47975. So we want to do 47975, which is this value in my CAS here, take away the earlier one. So the increase in the value of the investment from the second to the third year is $660.87. $660.87, so closest to $661. Okay, question 19. Daniel borrows $5,000 which he intends to repay fully in a lump sum after 1 year. The annual interest rate and compounding period for 5 different compound interest loans are given below. When fully repaid, the loan that will cost David the least amount of money is. Okay, so we want to actually work out the effective interest rate for each of these so that we can compare the effective interest rate. Now we shouldn't need to work out all of them because we should be able to work out some logic. So these 3 are all compounding with the same regularity, and so therefore the lowest interest rate out of those 3 is going to be the 12.6% interest rate is going to give us the lowest overall interest for these first 3 options, given that they're all compounding with the same regularity. So we only need to compare this one, and again we've got the same regularity here, compounding quarterly, and so the lower of these 2 interest rates, this one will be lower within those 2. So I'm going to compare these 2 options here. Okay, so effective interest rate is menu 8, 5 for interest conversion and 2 for effective interest rate. I'm going to put the annual interest rate 12.6, and then compounding weekly we are going to have 52 weeks. So that effective interest rate, so the effective interest rate here will be 13.41, and then 12.7%, oh sorry, we'll edit this previous calculation, so this time 12.7% compounding quarterly, so with 4 compounds, is going to give us an effective interest rate of 3.31, or 31, so 32 to the 2 decimal places, sorry, 13.32. And so therefore the lowest option is going to be loan number 4. So slightly higher interest rate, but with less frequent compounding periods, we overall end up paying less interest over the course of the 1 year, and so therefore we'll have a smaller amount to repay at the end of that year. Okay, question 20. The graph below shows the value of an asset as it depreciates over a period of 5 months. Which of the following depreciation situations does this graph best represent? Okay, it's not linear, it doesn't go down directly, it's curving, okay? And so therefore that tells me that it's not just a flat rate depreciation. So that allows me to rule out both A and B, it's not flat rate. It's also not unit cost. Unit cost is also essentially unit cost depreciation with a decrease in units. Okay, that's a bit different. So we'll come back and think about that. Can't rule that out straight away. So reducing balance, and it could be unit cost depreciation as long as we're seeing, if we used exactly the same number of units every month, then it would still look linear. But if the number of units, now let's just see what it says here. It says the unit number with a decrease in units used per month. So actually, a decrease in units used per month after 2 months. Okay, but if we use less units after 2 months, then we should be depreciating by even less, whereas actually we're depreciating by more, which indicates that we used more units in that month, and therefore that's why it depreciated more. So it shouldn't be decreasing in units per month, so I'm going to rule out C. A reducing balance depreciation with an increase in the rate of depreciation after 2 months. A reducing balance depreciation with a decrease in the rate of depreciation after 2 months. Okay, well, we do seem to have, well, actually, maybe I shouldn't have ruled out flat rate. Sorry, I hadn't read the options properly. With a decrease in, so because it all talks about what happens after 2 months. So if we treat this as 2 separate stages, so after 1 month, for the first 2 months, that's what happens, and that's flat rate. And then for the next 2 months, that's what happens, and that also looks to be flat rate. So I'm going to go back and not rule out flat rate. My apologies, I didn't read this looking at what happens after 2 months for all of these options. So I think it's flat rate depreciation with a decrease in the depreciation rate. No, the depreciation's increasing. It's depreciating quicker. We're losing more and more money. So we have an increase in depreciation rate after 2 months. So for the first 2 months, relatively low depreciation rate is going down by a smallish amount every month. But then after that, we go down. In fact, we can continue it right up to there. After that, we go down by a larger amount each month. So we've got a higher rate of depreciation. So option B for question 20. Sorry for misleading you initially there. Read the question is the key. Question 21. Which of the following recurrence relations could be used to model the value of a perpetuity investment after n months? Okay, so you can do a couple of things here. What I would probably do is just recur them. So a perpetuity investment means that Pn should stay the same all times. Stays the same. Okay, because all you're doing is you're taking out, your payment should be equal to the interest. Now we could work this out each time. We could work out what is 0.0029 of this, and is it the same as this, and if it is, then that's a perpetuity. But I actually think it's going to be more efficient to actually just recur what's happening here. So we're starting with 120,000. Let's multiply by 1.0029 and then take away 356, and if we still have 120,000, which we don't, then it would be a perpetuity. Okay, so we can see that that's going down slightly over time, so it's not that. It means this payment that we're withdrawing must be slightly more than the interest that's being added in each month. Okay, if we start with 180,000 and we multiply by 1.0047 and then take away 846, we still stay at 180,000 no matter how many times we recur it. So B is definitely a perpetuity investment. We could keep going and check the others, but I'll check the next one just to show you, but I don't think there's any need to check them all, given we found it at B. 210,000, multiplying that by 1.0071, and then taking away 1534. Okay, so that, now interestingly, that it changed in the first month. It went down slightly in the first month, but then it remains the same. But the fact that it went down in the first month means that it's not just a perpetuity. In that first month, this was more than the amount of interest. After that, this was the same as the amount of interest. But it's not a perpetuity because of that. It doesn't stay at $210,000 the whole time. All right, and the other ones, I'm sure we can, if you did the same, you could show that they are not perpetuities. It doesn't stay equal to $240,000 for the life of the loan or investment. Okay, question 22. Adam has a home loan with a present value of $175,260.56. The interest rate for Adam's loan is 3.72% per annum, compounding monthly. His monthly repayment is $3,200. The loan is to be fully repaid after 5 years. Adam knows that the loan cannot be exactly repaid with 60 payments of $3,200. To solve this problem, Adam will make 59 repayments of $3,200 He will then adjust the value of the final repayment so that the loan is fully repaid with the 60th repayment. The value of the 60th repayment will be closest to. Okay, menu 8.1. So we've got, I prefer to calculate it to the 60 months. I think it's easier. I'll talk about that when I get the answer. 3.72. Principal value is, and it's a home loan, so he's borrowed the money, so it's positive 175,260.56. He makes a monthly repayment, so he pays that money to the bank, so it's negative of 3,200. And what I want to work out, let me change my compound periods to be monthly first. I'm going to work out what would be the future value if I made 60 payments of $3,200. Okay, and the future payment would be negative $368.12, which suggests, because it's negative, that means that Adam still owes money. Okay, so if he only made 60 payments of $3,200, he still owes $368.12. So this means that the final payment, the 60th payment, for him to fully repay the loan, needs to be his regular payment of $3,200 plus the final payment of $368.12. So 3,000. Sorry. Let me go back here. Okay, because what I wanted to do was actually just. No, I'll just do it this way. 3,200 plus the $368.12, which would still be owing if he just made 60 payments of $3,200. So that is $3,568.12, which is option E. Okay, question 23. 5 lines of an amortization table for a reducing balance loan with monthly repayments are shown. The interest rate for this loan changed immediately before repayment number 28. This change in interest rate is best described as. Okay, so let's work out what the interest rate was initially, because we want to know what the change in the interest rate is. Okay, so if we think about, let's take this balance and this interest and work out what that is as a percentage of that. So original rate was 967.08 divided by 230,256.78. Times that by 100% to get my answer as a percentage. So what did I say? 967.08 divided by 230,256.78 times that by 100. Okay, so that is about 0.42% per month. And then we want the new rate. Okay, so this is per month. And the new rate, so when did it say it changed? The interest rate if this loan changed immediately before repayment number 28. Okay, so let's go to 28 and work out what's the interest rate at this point. So 1,002.26 over 227,785.76 times 100% to get as a percentage. 1,002.26 divided by 227,785.76 times by 100, and that is 0.44% per month. Now, the question's not super clear, but the interest rate for this loan is normally a per annum interest rate. So I think we need to actually compare the per annum interest rates. So if we do this times 12, the original rate is 5.04% per annum. Okay. The new rate, if we do that times 12, is 5.28% per annum, and so the difference is going to be that minus that, which is 0.24% per annum difference. So option A. Okay, and then the final financial maths question. So Mariska plans to retire from work 10 years from now. Her retirement goal is to have a balance of $600,000 in an annuity investment at that time. The present value of this annuity investment is $265,298.48, on which she earns interest at the rate of 3.24% per annum, compounding monthly. To make this investment grow faster, Mariska will add a $1,000 payment at the end of every month. 2 years from now, she expects the interest rate of this investment to fall to 3.20% per annum, compounding monthly. It is expected to remain at this rate until Mariska retires. When the interest rate drops, she must increase her monthly payment if she is to reach her retirement goal. The value of this new monthly payment will be closest to. Okay, so we need to work out what's going to happen for the first 2 years. So what will be the balance at the end of 2 years before the interest rate changes? Okay, so let's do menu 8.1. Let's think about the first 2 years. So it's monthly, but we're just looking at 2 years, 24 months. The interest rate for those first 2 years is 3.24%. The principal or present value is $265,298.48. Now that's her money, but she has given that to the bank, so it's gone away from her to the bank, so that's negative. She is going to continue to add in payments of $1,000 every month, so it's negative also because that's money going away from her towards the bank. And the future value is going to be positive because it's going to be relative to her positive money that she owns, $600,000. Oh, no, sorry, that's what we want after 10 years. We want to work out what the future value is. Payments per year and compounds per year are already 12 from our last calculation. Okay, so after 2 years, the balance is $307,794.50 to the nearest cent. Okay, so that's the balance after 2 years. So that becomes then the present value or the principal value for the remaining 8 years of the loan. So I'm going to copy this value and I'm going to paste it up here. Because she doesn't withdraw that money, it just keeps ticking over, so there shouldn't actually be a rounding happen. It's just a value in a spreadsheet at this point. It's only going to get rounded when she takes the money out. Hopefully, usually in the VCAA exams, the rounding of the final answer is such that whether you used a rounded number such as this, or whether you copied and pasted the exact number, you should still get the same value. But I always like to work exactly where I should. We want to know what she needs to increase her payment to if she wants to get to a value of $600,000, not in 24 months, it's in another 8 years. Okay, so we want 8 times 12 here. So in another 96 months, and sorry, we have to change the interest rate too, down to 3.2. So 8 years, interest rate 3.2, starting with the balance that she had at the end of 2 years and finishing with 600,000. What does the new payment have to be? Okay, and so the new payment is going to need to be 1854.05. So to the nearest dollar, $1,854. So hopefully, let's just check if I had rounded this to the nearest cent, and this is why. Oops. So it's actually still even the same to the nearest cent as well. So it's only a slight difference. Sometimes it makes a bigger difference than that. So just be careful about rounding. Okay, so that's the recursion and financial modelling, and then I'm going to do the 8 multiple choice questions of the matrices section of this exam. Okay, so question 1. Which of the following matrices has a determinant of 0? Okay, so you can get your CAS to work out determinants for you. Menu, 7 for matrices, 3 for determinant. Type the matrix in, get it to work it out. But personally, for me, it's quicker to do it by hand. So the determinant is AD, which is multiplying this diagonal together, minus BC, which is multiplying this diagonal together. And so determinant here would be 1 times 1, which is 1, take away 0 times 0, which is 0, so that would be 1. So it's not A. Determinant of B would be 1 times 1, which is 1, minus 0 times 0, which is 0, so that's also 1. Oh, sorry, I did this one around the wrong way. AD, which is 0 times 0, minus BC, which is 1 times 1, so that should be negative 1 for the first one. Regardless, it's not 0. Part C, determinant here is going to be AD, which is 1 times 6, so 6, minus BC, which is negative 3 times 2, so that's negative 6. 6 minus minus 6 is 6 plus 6, and so that's 12, so not 0. Determinant here in D, so not B, not C, is AD, so 3 times 4, which is 12, take away 2 times 6, which is also 12, so that's going to be 0. So it should be D. We can check for E. Determinant here, 4 times negative 2 is negative 8, take away 0 is negative 8. So D is the only one with a determinant of 0. Question 2, the matrix product is equal to. Okay, so if you do a 1 by 3 multiplied by a 3 by 1, you're going to expect to get a 1 by 1. So A is an option, B is not an option. C would give a 1 by 1 because that would be 1 by 1 and then you'd multiply by 4. So C is possible. D, all of these also actually give 1 by 1s. Okay. Alright, so we might just want to actually work it out. Personally, typing matrices into the CAS is slow for me, so I prefer to just type the calculation in by hand. So multiplying this together is going to be 4 times 4 plus 2 times 12 plus 0 times 8, which is 16 plus 24. Obviously, I can type this into my CAS and get my CAS to work that out for me. 16 plus 24 is 40. So you can check that if you want, either by typing in the matrices with your CAS or typing in the calculation with your CAS. But in D is 40, which is not A. Okay. So I guess we really just want to work out which of these will give us 40. The other thing though that you could do is, if you can recognize what's happening here, is our original calculation was 420 multiplied by 412.8. So what you might choose to recognize here, and there's a couple of different things here, but I'm seeing that there's 2 or 4 being taken out the front. Now this matrix here, the first one, if I divide that by 2, then it's the same as 2 times 210. And this matrix here, I could take 4 out of this, but then I would have a factor of 8 that I've taken out, which doesn't correspond with any of these. So if I just take 2 out of this instead, this becomes 2, 6, and 4. So actually, if I've got 2 times 2, that's 4, and then I've got 210 there, and then I've got 264 there. 210 and 264 with a 4 out the front is option E. You could also work back from the answers here. So obviously if we multiply this by 2, we get 420, which is what we've got up here, but we're not then multiplying it by the same matrix here, so it can't possibly give the same value. Again, this one here, we could put 2 of this in here, we could put 2 in there, and we could put 2 in there, and so this would become 240, which is what we, actually no, that's not even right, is it? They're around the wrong way. So we should probably check though that this just doesn't give the same value. I might just do this multiplication, just check that it doesn't give me 40. In fact, again, I'll do the multiplication by hand. I'll leave the 4. I'll just do the matrix multiplication. So we're going to have 4 times. It'll be 1 times 1 plus 2 times 12 plus 0 times 8. So that is 4 times 1 plus 24. 4 times 25, which is 100. So not 40. So E should be the only one that gives me 40. And again, you can check it. So a combination of, again, not necessarily having to work them all out, combination of logic, ruling some options out, testing between some of the remaining options. Okay, question 3. 5 people, India, Jackson, Krishna, Leanne, and Mustafa, competed in a table tennis tournament. Each competitor played every other competitor only once. Each match resulted in a winner and a loser, so there are no draws. The matrix below shows the tournament results. Okay, you expect to see some sort of symmetry in these. So 0's down the diagonal because they don't play themselves, and then if there's a 1 here, there should be a 0 diagonally opposite that leading diagonal, because if J lost to L, then L beat J. Okay, so that's where for every number here we should see, for every 1, so this 1 over here, there should be a 0. Okay, so you can't have 1s in both of those positions because that would suggest that both M beat K and K beat M, which is not possible. Okay. Alright, so sometimes you might get a question like that where they leave some blanks in the matrix that you need to fill in by simply thinking about that sort of symmetry. A 1 in the matrix shows that the competitor named in that row defeated the competitor named in that column. For example, the 1 in the 4th row shows that Leanne defeated Jackson. So Leanne defeated Jackson. Again, winner, loser. A 0 in the matrix shows that the competitor named in that row lost to the competitor named in that column. There is an error in the matrix. Okay, this is what we want to work out. The winner of one of the matches has been incorrectly recorded as a 0. So I should have actually continued with my earlier conversation, which was about checking that if I look at the numbers diagonally opposite the leading diagonal, okay, one should be a 1 and one should be a 0. So this is okay. This one's okay. This one's also okay. There. So that's the one there. Both a 0 there and a 0 there suggest that Mustafa did not beat India, but also India did not beat Mustafa, which is not possible. So it's about the match between India and Mustafa, which is option A in question 3. Okay, question 4. Matrix P is a 4x4 permutation matrix. Matrix W is another matrix such that the matrix product P times W is defined. This matrix product results in the entire first and third rows of matrix W being swapped. The permutation matrix is. Okay, so what you might want to do is just, I think it's easier to kind of actually think through the options here. So if you have a 4x4 times a 4x1, it's going to also give you a 4x1. And if we think about actually, so we want the first and third rows to be swapped. Now, if you were to do row times column here, 0 times A plus 0 times B plus 0 times C plus 0 times D, you're going to get D up the top here. Okay, and so that means that the first, that the 4th row has gone to the 1st row, which is not what we wanted. Actually, the other issue a check I'll do before I do any of these further calculations, is in a permutation matrix, you must only have 1 in each row or column, because what we would find here when we do the bottom row times the column, we get D down here again, okay? When we do the 2nd row times the column, we're going to get a B, and when we do the 3rd row times the column, we get a C. So actually, we haven't just rearranged it. This isn't a permutation matrix. It's created a different matrix. We've lost A, and we've gained a second D. So, and that's because of the 2 1s happening in that row. So before I do anything, I'm going to rule out any that aren't permutation matrices. So we need to have a single 1 in each row and in each column. So this one's okay. This one's an issue. Oops, sorry. That one's an issue there. Sorry, just changed the zoom. Let me just fix that. Okay, so seem to be having trouble here. Okay, so C we're ruling out because we've got it's not a permutation matrix. D also isn't a permutation matrix. So therefore, and E also isn't a permutation matrix. So actually, B is the only one that is a permutation matrix. So regardless of whether or not it swaps the 1st and the 3rd rows, it's the only one that can even possibly do that. Let's just check it. But yeah, this is a nice one that with a bit of thought and some process of elimination, you should be able to actually get down to the answer without needing to really do any calculation here. Okay, so row times column, 0 times A plus 0 times B plus 1 times C plus 0 times D. So we're just going to have one lot of C. That's going to go up the top there. So that is the 3rd row going to the 1st column, so that looks good. 0 times A plus 1 times B, we're going to have a B there. 1 times A, we're going to have A there, so that is the 1st row going to the 3rd column, and here, the 1 here will mean we end up with 1 times D, which is D. So we have indeed swapped the 1st and the 3rd rows here, so B is the correct response to question 4. Okay, question 5. Liam cycles, runs, swims and walks for exercise several times a month. Each time he cycles, Liam covers a distance of C kilometres. Each time he runs, Liam covers a distance of R kilometres. Each time he swims, Liam covers a distance of S kilometres. Each time he walks, Liam covers a distance of W kilometres. The number of times that Liam cycled, ran, swam and walked each month over a 4-month period, and the total distance that Liam travelled in each of those months are shown in the table below. The matrix that contains the distance each time Liam cycled, swam, ran and walked, CRSW, is. Okay, so this can be set up into a series of simultaneous equations. This essentially, if he cycles 5 times and each time he cycles C kilometres, 5C is the distance he cycles, plus 7R is the distance he runs in month 1, plus 6S is the distance he swims in month 1, and 8W is the total distance he walks in month 1, and so therefore that has to equal his total distance for that month. So what we essentially have here is 4 simultaneous equations, which are just going to be that. 8C plus 8R plus 5S plus 5W equals 162. So there's your 4 simultaneous equations. So they can become a matrix equation. It's going to be, 5, 7, 6, 8, 8, 6, 9, 7, 7, 8, 7, 6, 8, 8, 5, 5 times CRSW, and we know that that equals 160, 172, 165, and 162. So to solve this matrix equation, we're going to need the inverse of this. So it's going to be CRSW is equal to the inverse of that square matrix times that matrix. Okay, so we can get our CAS to do that. A 4x4 matrix, that is 5, 7, 6, 8, 8, 6, 9, 7, 7, 8, 7, 6, 8, 8, 5, 5. We want the inverse of that, and we want to multiply that by our 4x1 matrix, which is 160 times 172 times, 165, 162. And that's going to be equal to 8619. 8619, so option B. The other thing for those of you that are reasonably comfortable with the algebra of it, personally I find having to type in matrices, particularly a 4x4, it's very cumbersome and very tedious. I probably would have straight back from here not even bothered formulating the matrix equation, and instead menu 371 solved a system of 4 equations where the unknowns were C, R, S and W, and then you simply type in the equations. 5C plus 7R plus 6S plus 8W equals, equals 160. Type in the other 3 equations, press enter, it'll tell you what C, R, S and W are, and therefore you can work out which matrix is the answer. It's still quite a lot of typing in, but I just wouldn't even have bothered, I just wouldn't even have bothered of formulating this into a matrix equation and then having to think about the inverse and all of that. I just would have solved the simultaneous equations directly with my CAS. But regardless, option B is the correct answer for question 5. Okay, question 6. A transition matrix V is shown below. The transition diagram below has been constructed from the transition matrix V. The labeling in the transition diagram is not yet complete. The value of X is. Okay, so now there's quite a lot of labeling missing here. So we need to actually use the numbers that are already here to work out what each of the nodes in the network is equal to, whether it's LT, F or M. Okay, so let's start here. So we've got, I'm going to have a look at this one first. So 0.2 leaving it and 0.1 coming into it from somewhere else. Okay, so let's have a think. So, or actually no, I'm going to start with the 0.4 because there's only one 0.4 in the whole matrix. So that's easier to identify from the matrix. Okay, so that tells me from my matrix that from M to F is 0.4. So that means this must be M and this must be F. Okay. All right, so therefore it's between M and somewhere else that isn't F that we have from M to somewhere else is 0.1. So from M to T is 0.1, okay? And therefore from T to M is 0.2. Yes, that makes sense. Okay, so this must be T down here. which means that the remaining one, this one must be L over here. And so therefore X is the proportion of, don't even know what this is about, things that go from L one month to staying at L the next month. So that's going to be this number up here in the matrix, so X must be 0.6, so C. Okay, so question 7. A study of the antelope population in a wildlife park has shown that antelope regularly move between 3 locations, east, north and west. Let AN be the state matrix that shows the population of antelope in each location n months after the study began. The expected population of antelope in each location can be determined by the matrix recurrence rule. Okay, so we've got a transition, but also a subtraction, so that's probably the antelopes that are dying. Well, the net change from deaths, births and deaths. So we have our transition matrix given here, and we've got our D matrix here. So we're seeing that every month, was it months? Yep. Every month we're taking away 50 antelope from the east location, 50 from the north location, and 50 from the west location. So gradually the population seems to be decreasing by 150 antelope each year. The state matrix A3 below shows the population of antelope 3 months after the study began. The number of antelope in the west location 2 months after the study began is found in the state matrix A2 is closest to. Okay, so we've been given A3 and we want to find A2. So according to the recurrence relation, we know that A3 is going to be the transition matrix times A2 take away D. So if we want to solve, we know what A3 is and we want to solve for A2, so we need to rearrange this matrix equation. So A3 plus D will be the transition matrix times A2, and then we're going to need to use the inverse matrix to cancel that out. So we're therefore going to need the inverse of t, but it has to go on the left. It has to multiply everything, it has to multiply the whole left-hand side of the equation from the left by the inverse of t. Alright, so we get that A2 is the inverse of t times A3 plus d. So we can do that. Let's type all that in. So I need a 3 by 3 matrix. Oops, sorry. I need a 3 by 3 matrix, which is 0.4, 0.2, 0.2, 0.3, 0.6, 0.3, 0.3, 0.2, 0.5 to the power of -1, so -1. So inverse transition matrix, and then we need to multiply by matrix A3, which is here, so that's a 3 by 1 matrix. 1616, 2800, 2134, and then plus matrix D, which is also a 3 by 1 matrix, which is 50, 50, and 50. Alright, and so we find that A2 is 1630, 2800, 2270, and so we want the number of antelope in the west location, which is this bottom one, which is E. Okay, and then question 8, the final matrices question. A public library organised 500 of its members into 5 categories according to the number of books each member borrows each month. These categories are J, K, L, M and N. The transition matrix T below shows how the number of books borrowed per month by the members is expected to change from month to month. In the long term, which category is expected to have approximately 96 members each month? Okay, so using the transition matrix and raising it to a large power, we can work out the long-term proportion for each category. So what I kind of want to think about first is what proportion would give me 96 members, okay? So if I need, we want to have, there's going to be 96 members out of the 500 members in a particular category, which is 96 divided by 500, which is 0.192. Sorry, not 0, yeah, 192. So we want that proportion, that long run proportion, which category has that long run proportion. So then I'm going to do my transition matrix to a big power. So, sorry, I need to type in my transition matrix again. Quite a lot of big transition matrices to type in this exam. So it's a 5 by 5 matrix, 0.1, 0.2, 0.2, 0, 0, 0.5, 0.2, 0.3, 0.1, 0, 0.3, 0.3, 0.4, 0.1, 0.2, 0.1, 0.2, 0.1, 0.6, 0.3, 0, 0.1, 0, 0.2, 0.5. Okay, and we want to raise that to a big power. Oh, sorry, not equals. To the power of, I usually use 50. It's usually more than enough. If you really want, you can get to 51, but even if it's not exactly at 0.192, we should be able to work out which category gives us a proportion of about 0.192, and that seems to be the second row. So what you notice when you raise the full transition matrix to a big power, then every number, the whole row should be equal to the same proportion if you've reached the steady state, which it looks like we have. So it's telling us that so about to nearest percent, 10% of people are in the, or 9.8% of people are in J category, 19.2% are in K category, which is the category that we clearly want. 24.8% are in L category in the long run, 30.2% in M category, and 15.9% in N category. So K is the one that gives us a long run proportion of 0.192 and hence a long run proportion of about 96 members. So option B. Okay, that's the end of the core sections and the matrices module for the 2018 Exam 1 in Further Maths.